all about utilizing pivotal element method and Chio's method in finding determinants.
Right after this video presentation, viewers are expected to explain pivotal element method and Chio's method in their own way, and also increase their analytical skill in solving matrices, and of course, gain more knowledge about pivotal element method and Chio's method.
So what is the purpose of this video? So first, to give student a free academic videos. Second, to fully understand the Chio's method using the student point of view. And lastly, to fully understand the pivotal method using the student point of view. That's all. See you in the solving part.
Our first topic is about pivotal element method. The pivotal element method is one of the useful methods in evaluating a determinant. In getting the determinant of a matrix of order n, the pivotal element method centers its solution on finding a pivot element, which is 1, and creating an n-1 determinant from here.
Allow me to demonstrate to you the solution on how we are going to do the pivotal element method. Dito, mayroon tayong third order determinant at gagamitin natin yung pivotal element method sa paghahanap ng ating determinants. We must first choose our pivot point at nandito lang yon within the given matrix. And also, we have the requirement na dapat ang pivotal element natin must be equivalent to 1. So, dito sa example natin, we only have one element that is equal to positive 1 or 1. Makikita natin ito sa second row, dito sa second row, and third column. So, we'll just need to mark it or highlight it para hindi tayo malito. So, ano naman yung gagawin natin kapag wala tayong nakitang 1 sa given matrix natin? Ngayon, pwede tayong pumili ng kahit anong element sa loob. Halimbawa, we can use this element, pero gagawan natin ng paraan para maging 1 siya. For example, pinili natin itong 4 na to as a pivotal element. To make this 1, you have to divide it by 4. So, i-divide natin siya sa 4. Ibig sabihin, kailangan natin mag-factor out. So, pipili ka lang kung saan mo to i-factor out, yung 4. It's either you factor out dito sa column na ito, kung saan siya located, or dito sa row na to. Kung pinili natin na i-factor out siya dito sa column na to, so 4 divided by 4 is equal to 1. So magiging 1 to. And then, negative 3 divided by 4 is magiging siyang negative 3/4. And this will become 3 halves. Kung pinili naman natin itong row na to, we'll have 4 outside the determinants, and then this will become 1, 3/4, and also 1. Okay, that's how you choose a pivotal element on the determinant that doesn't contain the unity element 1. But since the example given has an element 1, we are going to use this as our pivotal element. So dito, iikot yung solution natin. Since namarkahan na natin ang ating row at column kung saan located ang ating pivotal element or pivot point, from 3 by 3 determinant, naging na siyang 2 by 2 determinant. Bakit? Kasi ito na lang po ang matitira. 4, 6, 3, and 5. But when we are solving, we are going to make use of these columns and rows that are omitted from our solution. So instead of completely deleting them from your determinants, pwede tayong gumamit ng marker or highlighter, katulad na ginamit natin, to cover that part. And the solution for the pivotal will be, there will be always a negative 1 raised to the sum of the position of our pivotal element. So, it is at A, 2, 3. Therefore, this will be negative 1 raised to 2 plus 3. So, by the n-1 determinant, we've come up with this 1. Since kinross out na natin ito, we have now 4 and 6. And then, maglagay tayo ng space dito. Kasi, maglalagay tayo ng solution dyan mamaya. And also, we have 3 and 5. Okay, right after that, you are going to subtract from each remaining element after we mark or omit yung portion na dinaan ng ating pivot point. So, ito yung isusubtract mo. You will subtract yung product ng element na nag-intersect doon sa 4 natin. So, kung ito yung entry, kukuhanin mo yung katapat niya. Yung pivotal row and yung pivotal column niya. So, that would be 4 multiplied by negative 3. Dito naman is negative 1 and negative 3. So, 6 minus the product of negative 1 times 3. So, next, we're going to subtract this sa product ng ating 4 and 2. So, 3 minus the product of 4 times 2. And then, dito naman is negative 1 and 2. So, 5 minus negative 1 times 2. So, hopefully, naiintindihan nyo itong part na to kasi pagdating natin to sa 4x4 or sa 4th order determinant, parehas lang yung magiging solution natin. After this, isimplify na natin. So, negative 1 raised to 5 is negative 1. And multiply by the remaining 2x2 determinants. So, that's 4 plus 12 is 16. 6 minus 3 is 3. And 3 minus 8 is negative 5. Lastly, we have 5 plus 2 is equal to 7. Then, proceed na tayo dun sa simplification using the Leibniz formula. So, huwag natin kakalimutan to kasi lagi ito yung nakakalimutan. Then, hold on. So, this will be 16 multiplied by 7 minus 3 multiplied by negative 5. This. So, this is now equal to 127. And right after na makuha natin tong determinants na to, don't forget to multiply it by negative 1. Therefore, our final answer here is equal to negative 127. Earlier, we explained on how to find our determinant by using pivotal element method in third order determinant. Now, let's try to find out the determinant in this given example, which is 4x4 determinant. The first thing to do, of course, is to find out our pivot point or yung pivotal element natin. If the given determinant of order has an element of 1 or unity, choose the particular element. Since dito, mayroon tayong isa, dalawa. So, dito, mamimili lang tayo ng isa. Let's choose this one. Yung nasa second row and third column. If wala naman tayong 1 sa given example, we can choose some convenient element, just like what we did earlier, yung nag-factor out tayo. And then, let's proceed to our next step. Don't forget this one, negative 1 raised to 2 plus 3. Dito tayo kukuha ng product na isusubtract natin sa element. So, we will go into subtract all of these terms na nag-intersect sa ating elements. So, kukunin ulit natin yung mga remaining elements sa loob ng ating 4x4 determinant. Negative 5, 1, 21. And again, mag-iwan tayo ng space para sa solution natin mamaya. 25, negative 3, 6, and 10, negative 2, and 4. And now, we are going to subtract all of the remaining elements sa product ng ating pivotal column and pivotal row. Saan? Nag-intersect yung pivot point natin. So, negative 5 minus 3 multiply by 3. Next, 1 minus the product of negative 1 and 3. 21 minus the product of 5 multiply by 3. And the next, 25 minus 3 multiply by 2. Negative 3 minus negative 1 multiply by 2. And 6 minus 5 multiply by 2. Next, 10 minus the product of 3 and also 3. And negative 2 minus the product of negative 1 multiplied by 3. Lastly, we have 4 multiplied by 9, by 5, and 3. And as we notice this one, makikita natin yung pattern. And because kung makikita natin tong column na to, we have 3, 3, 3, 2, 2, 2, 3, 3, 3, and this row, 3, 3, 3, negative 1, negative 1, negative 1, and 5, 5, 5. Para hindi tayo malito, sundan lang natin tong pattern na to. Para makita natin kung tama ba yung answer natin or yung process na ginagawa natin. And we must simplify this one, of course. Negative 1 raised to 5 is negative 1. So we have to multiply this by the product of these remaining elements. So negative 5 minus 9 is negative 14. And 1 plus 3 is 4. And this one is 21 minus 15 is 6. 25 minus 6 is 19. Negative 3 plus 2 is negative 1. And this one will become negative 4. And then minus 9 is 1. Negative 2 plus 3 is 2. And this one will become 19. Correction lang po. This is not 2, rather this is 1. And now, we've come up with a 3 by 3 determinant. You can apply now the basket weave method or the cofactor solution. Since yung topic natin is all about utilizing pivotal element method, so i-continue na lang natin yung paggamit ito. Gawin ulit natin yung step. Good thing na meron tayong 1 na nakita sa 3 by 3 determinant natin. So, choose either this one or this one. So, ito na lang yung piliin natin. Yung pivot point na nasa second row and third column. And then, let's proceed to the next step. Sulat lang natin to. And then, don't forget this negative 1. Tapos, yung pivotal element natin, negative 1. Raise to 2 plus 3. What are we going to do is to write all the remaining elements, which is 14, 6. So, maglib-ulit tayo ng space para sa ating solution. 19, and negative 4. We will now going to subtract all of these remaining elements kung saan nag-intersect ang ating pivot point. So, negative 14 minus 1 multiply by 4 and 6 minus 19 multiply by 4. 19 minus 1 multiply by negative 1. And negative 4 minus 19 multiply by negative 1. So, may pattern ulit tayo dito. Makikita natin dito sa column 4, 4, negative 1, negative 1. Dito naman sa row 1, 1, 19, and 19. Para hindi tayo malito, so check lang ulit natin tong pattern na to para makita natin na tama yung process na ginagawa natin. At isimplify na natin tong solution na to. This will become negative 1 multiplied by negative 1 raised to 5 is positive 1. And then, isolve natin itong mga remaining elements na to. This will become negative 18. And this will be equal to 82. And ito naman is 20. And this one will be negative 23. So, all we have to do is to use the Leibniz method. So, ayan. This will be equal to, so wala tingnan kalimutan po 1. Negative 18 multiply by negative 23 minus 82 multiply by 20.
And now, this will be equal to negative 1,226. And that's how we solve the determinant using pivotal element method. And now, let us proceed to Chio's method.
So in this video, we will show you on how to solve the different type of matrices using the Chio's method. First, let's have our given matrix R is equals to its first row 1, 3, 3, second row 2, 1, 2, third row is equals to 3, 2, 2. So in solving using Chio's method, first we need to identify that the A11 or the first element should not be equal to 0. And in this case, it is a 3 by 3 matrix. So Rn will equal to 3. So the determinant for R is equals to the formula 1 over the first element, which is 1, raised to n, which is 3 minus 2. And then we will copy the given element. So in solving the determinant for R, first is equals to 1 over the first element, which is equals to 1, the n, which is equals to 3, and the 2 here is a constant number. So to solve the determinant for R, first we need to group the different element. So for our first group element, we will use the first row, first column, and then the second column, which is 1 and 2, 3 and 1. For the second group element, we will use the first column and the third column, which is 1 and 2, 3 and 2. So for the third group element, we will use the first and third row, which is 1 and 3, and the second and third row on the second column, which is 3 and 2. So for the fourth group element, we will use the first and third row of the first column and the first and third row of the third column, which is 3 and 2. So to solve the group element, first we need to cross multiply the given element, and then we will subtract each product. So in this case, 1 multiplied by 1 is equals to 1 minus the product of 2 times 3, which is 6. So 1 minus 6 is equals to negative 5. So in the second group element, we will do the same process. So 1 times 2 is equals to negative 2, and the 2 times 3 is equals to 6. So 2 minus 6 is equals to negative 4. So in the third group element, 1 multiplied by 2 is equals to 2 minus 3 multiplied by 3 is equals to 9. So 2 minus 9 is equals to negative 7. So on the fourth group element, 1 times 2 is equals to 2, 3 times 3 is equals to 9. So 2 minus 9 is equals to negative 7. So to solve this, we need to simplify the given formula here. So 1 over 3 minus 2 is equals to 1. 1 raised to 1 is equals to 1. So 1 over 1 or simply 1. So to solve this element, we will do the same process like here. We will do cross multiplication and then we will subtract the product. So in this case, 5 times 7 is equals to positive 35. 7 times negative 7 times negative 4 is equals to positive 28 minus positive 28. So we will do the KFC, keep, flip, and then change the sign. So 35 minus 28 is equals to positive 7. So the determinant of R is equals to 1 over 1 or simply 1 and positive 7. So 7 times 1 over 1 is equals to 7. So in this 3 by 3 matrix, our determinant here is positive 7. So for our second example, in solving the different types of matrix using Chio's method, we had first matrix B is equals to its first column, which is 0, 3, 2, second row 3, 1, 2, and its third row 2, 3, 3. So in this given matrix, the A11 or the first element is equals to 0. So we can't use the Chio's method unless we will transpose the first column to the second column or the third column. So in this case, we transpose the first column to the second column so that our A sub 1 or the first element will not be equal to 0, and we will use the Chio's method. So here we transpose the first column 0, 3, 2 to the second column, which is 3, 1, 3. So our first column now is equals to 3, 1, 3. Our first row we will transpose is 0, 3, 2. We will the second column. So and then the third column we will copy the 2, 2, 3. So it is a 3 by 3 matrix. So Rn will equals to 3. In solving the determinant for B, first we will use the formula 1 over the first element, which is A11 raised to n minus 2, and we will use the transpose given, that is 3, 1, 3, 0, 3, 2, 2, 2, 3. So we will substitute here the given, the A11 or the first element, which is 3, 1 is equals to negative 3, and the n, which is 3 also, minus 2. The 2 here is constant. So to solve the determinant for B, we will group each element so that we can do the cross multiplication and then multiply its given product. So for the first group of element, we will use the first column and the second column, which is 3, 1, 3, 1, 0, 3. So for the second group element, we will use the first column and the third column, which is 3, 1, 3, 1, 2 and 2, 2 and 2. So for the third given group element, we will use the first and third row of the first column, which is 3, 3, 3 and 3, and the third row of the first and third column, which is 0 and 2. And then for the fourth given group element, we will use the first and third row, which is 3 and 3, and in the third column of first and third row, which is 2 and 3. So here, so we get our final answer. We will do the cross multiplication and then subtract their given product. So here we will 3 multiplied by 3 is equals to 9, minus 1 multiplied by 0 is equals to 0. So 9 minus 0 is equals to 9. So for the second one, we will 3 multiplied by 2 is equals to 6. 1 multiplied by 2 is equals to 2. So 6 minus 2 is equals to 4. So in the third, 3 multiplied by 2 is equals to 6. 3 multiplied by 0 is equals to 0. So 6 minus 0 is equals to 6. So here, 3 multiplied by 3 is equals to 9. Minus 3 multiplied by 2 is equals to 6. 9 minus 6 is equals to 3. So to get the determinant of B, we will repeat the same process here. We will cross multiply the 2 and then we will subtract each product. So 9 times 3 is equals to 27, minus the product of 6 times 4 is equals to 24. 27 minus 24 is equals to 3. So the determinant of B is equals to 1 over 3 multiplied by 3. So 3 multiplied by 3 divided by 3 is equals to 1. So the determinant of B here is equals to 1.